My projects are often about integrating modules, and that can make using KICad to design a PCB scary. There are easy ways to create symbols and footprints that will get you through though. Using my Advent Calendar project, let me show you how. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, Robotics, IoT and other fun tech. Remember to subscribe and join the community. So I've already built my Advent Calendar project on a prototype board and it works great. Though to be honest, there are a few problems with how I connected things and it took me a whole day to solder this up, which is way too long. Even on a simple project like this, fabricating a PCB can be the right thing to do. PCBWay helped me out with this PCB for this project. Their low cost and quick turnaround make them an ideal fabricator for PCBs like this. Well, there is also that scary part of using modules in KICad, which means hunting for or creating your own symbols and footprints. If I can do that, so can you. I want to show you one other really cool trick in KICad and Blender too. I designed my project cases in Blender and it's always taken me for ages to get holes and cutouts to line up with the components on the PCB. I've found how to extract the PCB model fully populated from KICad and import it into Blender so I can see the PCB as I'm designing the case. This makes things so much faster. Keep watching to see how I do it. If you like this video and it helps your learning or projects, why not drop me a cash tip using the super thanks button below the video or other payment method in the description. I'm saving these up to get myself to open source in San Francisco next year, and I appreciate your help in getting me there and I hope to see you there too. Please hit the like button on the video and subscribe for more. So in this video we're going to focus on that PCB design and the particular problems actually for designing this sort of project for a hobbyist, which is really about modules. So we're going to use KICad, and KICad split the design process into two phases, which makes a lot of sense to work on the schematic, so actually how the circuit actually connects and how all those components and modules connect together, and then how we're going to lay that out on the PCB itself. Now the reason for splitting those is that actually the choice of the footprint of those components, actually we often have choices. Sometimes modules might come in multiple footprints, components certainly do, and we get to choose between those two. The schematic and the design of the circuit remains the same. Once we've got that PCB layout, we can actually then extract the files and send it off to a fabricator like PCBWay, and a week or so later we get back our lovely board and we save ourselves a load of time to solder it up. The other really neat thing I like about using KICad, which I've only really just discovered, is that there is an extension that allows us to actually go into the world of case design and designing the models, because I can extract my PCB design as a 3D model and then import it into the world of Blender. And Blender is where I do a lot of my 3D design. So I can then build out my case in Blender, and then I can extract that and I can print that either on my own printer, or I can again send that off to a fabricator like PCBWay to print as three-dimensional objects. This video is sponsored by PCBWay. And I'm thinking about them from this video as a fabricator to be able to fabricate the PCBs we're designing through KICad, and to actually 3D print the models of the cases that I'm designing through Blender. Now of course PCBWay do lots more, from CNC to sheet metal to the actual assembly of PCBs, as well as having a module store where you can buy modules, and hosting community sites where we can actually see lots of other people's projects and get inspiration. I'm going to share all of the files for today's build, and indeed the build of this project, this Advent Calendar, on GitHub, and it can be found in this repo. Occasionally I get things wrong and don't share everything, so if I've got an issue with the repo, please do let me know and I will fix it. So we're going to do all our design in KICad, and we're going to go and first focus on the schematic. I'm not going to show you here how to connect up to lots of discrete components. What I'm going to talk about is the real problem, I think, with KICad for us hobbyists, which is how we work with these modules. And in this project, I've got quite a lot of modules. So we've got the RP2040 Touch LCD screen itself, and that's basically got header pin connections coming out of that via that connector at the top there. And then I've got a chroma dot, which I'm using as my real-time clock. And I've got a level shifter, which I need to actually reliably drive all of those WS2812B LEDs. So first of all, let's talk about the module. So how are we going to do that? Well, we've got a SH10 connector, which they kindly give you one free with that, with a cable with DuPont female connectors on the other end. So that's great. So actually what I'm going to focus on is just putting in the connector for the DuPont female connectors, or DuPont male connectors onto the board with that set of connections on it. That's fairly easy to do, but there are a couple of tricks on that. So I'm in KICad and I'm in the schematic editor, and my connector to this screen is down here, and it's this component here with that set of connections running off that. Let me show you how I put that in. So first of all, I'm going to say I want to add a new symbol. So I'll go and select the symbol adding, and I'm going to tell it that it is a 1 by 12 symbol that I want to add in. Let's make that a little bit larger so you can see what I'm doing here. And it's going to give me a set of options here. And I'm going to say, actually, I want a generic connector that's 1 by 12 and it's a pin header. And that's the one I select. And I'll bung it up there for a second. The next thing I'm just going to do is switch to the normal selector, and I'm going to push E to edit it, because I want to immediately put in the footprint for it as well, because footprint's what we're going to use in a bit. And going through the set of footprints, I'm going to look down for a connector that's pin header, and it's got the 2.54mm pitch, which is the right pitch for a DuPont connector. I mean, it's a standard pitch that you use on a breadboard as well, and it's one I tend to use all the time. Really, other pitches I'm sure are useful, but for me as a hobbyist, most of the time I'm on this sort of pitch. So I then look down here and find 1 by 12s, and I've got several options here. I could go horizontal, vertical, those are both through hole, or I could do some surface mounts. I'm definitely going to go through hole on this, and actually I want horizontal. So that's what I'm going to select. Now that theoretically is it. You've got your connector, and we can just start connecting up from it. But actually I want to make it a little bit easier for me to see what's going on. So I'm going to edit the symbol. And that takes up and loads up the symbol editor here. And you'll see that we've actually got a number, and indeed there is a name for each of the pins on here. And it's that name that I'm interested in, and I'm just going to select the table there, because I can then see all the names here, because I can then start changing them to stuff that actually makes sense for what I'm connecting. Because I'd rather it didn't say pin 1, I'd rather it said ground, because that helps me then when I'm connecting it up. And if I go and do a Blue Peter, for my UK viewers who will know what that means, go and save that back. So if I go and do a Blue Peter and have a look at this one, which is the actual connector, and we have a look at the symbols on here, and I load those up, you'll see that actually, well, in fact, it's better, easier on the diagram, I've actually named them all exactly as they are for our connector, and that makes life really much easier for me. I guess the final little trick I'm doing here, which I thought made life a little bit easier for me as well, was that actually I've not just connected everything to everything. What I've actually done is constructed nets and labeled nets. So these are a labeled network of connections, connection by symbol name rather than connection by wire, which is useful to stop me having wires crossing everywhere when I've got lots of connectors that are doing lots of things. It just made it a little bit easier to draw this out. Where this used to become a little bit more scary for me is when we want to actually put in a module like the logic level shifter here, which it's only 8 pins in 2 rows, but I haven't got a standard symbol or footprint for this. And of course I can hunt around the internet to try and find one, but they're not always that easy to find. I could post in some forums to ask, and I'll probably get a lot of spam and abuse back, because generally the advice will be, well, build it yourself, it's easy. And actually it generally is. So we want to put in a level shifter. Now this is not going to be in anyone's library, or not reliably. Really what we need to do is create our own for our own project, and we do that by creating a symbol first, and then we'll create a footprint later. But let's start with the symbol. So we'll go into symbol editor, and this is really nothing to be scared of. The way I do it is basically to start by going and finding something that's a bit similar, like for instance a 4-pin connector. That's nice and simple, and we can just put another 4 pins on the other side and we're good to go. So why not do that? So that's what I'm actually going to do. So I'm actually going to save a copy of this, and I'm going to save it into my own little repo for symbols, or library for symbols, which is called Dr Jon EA. There we are. And I'm going to call this Dr Jon level shift. So now if I go down and find Dr Jon repo there, or library, there we go. We've got a Dr Jon level shift, and it is the same symbol. It's changed its name down here, which is good, but it is the same symbol. So we can now edit it and say, well, actually, let's have that block a little bit bigger. Then we're going to need, then we're going to need some additional things on here. So I need the level 1 output. On the right hand side, well, let's quickly go and rename a few things so that we've got what I think is correct here. So pin 1 is going to be high voltage 2, pin 2 is going to be ground, pin 3 is going to be high volts, pin 4 is going to be high volt 1. Show pin names, please. Right, so we've got the pin names there for the one side. Now let's start creating the other side. So LV2 is going to be pin 8. And I'll just rotate that. And then move that into position. There will be fine for the second. Ground. Low volts, which is going to be pin 6. I think I've got to put a pin number on the ground. And LV1 is going to be 5. I'm not worrying too much about changing the electrical characteristic of these. I probably should be, and adding it all properly, but I'm just doing this quickly so that this doesn't take me too long. I'll show you one that I've done properly in a second. But basically this is all you need to do to give us a new component, which we can then use. I'm just going to make that a little bit smaller though. So that sort of is neat enough, gives us all of the connections. If I have a look at that, they're all there in that table. I can save this now like that, make sure that's all nicely saved, and then we can go back into KiCad and I can actually go and have a look at this repo or this library. Sorry, It's not really a repo, it's a library. And there we go. And I can just bung my component there and then connect it up. That's the easiest way to get a new symbol in and go with it. The actual one I used in the model, I will delete that, is over here. And you see that's a little bit more proper because I've actually said, you know, what the power is and things like that. So the other part of this for our level converter is we need a footprint, and we can do that in the footprint editor. And again, it's not really any more difficult than it is to do any other sort of layout in KICad. So again, I'm going to pick something that looks very like what I'm going to end up with. So I'm going to again start with a 4-pin connector, and I'm going to go with a vertical one. There we go. And I'm going to say I actually want to again duplicate that. So I'm going to save a copy of it, and I'm going to call it Dr. Jon's level shifter. And again, I'm going to save it to a different place. So I've got my own little library here for footprints called Jon's library, and I'm going to put it in there. Right, so now if we go and grab Jon's library and look at our level shifter, and there it is. So the first thing I really want to do in here is then draw something that is round the right size for our actual PCB in our component. And I can do that on the silk screen, and I can draw a size object to give me the right size, and then I can go and load it up and edit it, and I can make it exactly the width and height that I need for that PCB. And I use that changing its size and making it actually fit as the way to just make sure I've got the right spacing, etc., and just give me a visual guide. And then I can do things like, you know, duplicate all of the components, put on these additional connections, and as long as I get the numbers right and the numbers in the right place, that will then match back to my symbol. So that's all I need to do is the numbers of these are key, and their positions then become really, really important to me too. So if let's see if I can just duplicate that lot. There we go. Duplicate that lot over there, and then I will want to go in and actually renumber them and say that that's now actually pad 8. That becomes pad 7. That's 6. And that's 5. Now the really key bit, I guess, in playing around with this is distances and sizes. And we've got this wonderful measurement tool in here, so I can actually measure the distance between there and say, actually, does that line up to what I'm actually expecting it to be on my board, and does it actually look like it will fit? So that's the first part of that sort of measurement, and trying to get this lined up and to look the way I need it to look, so that I've actually got the layout. The other part of this, or the other test I use, is to print it. And I can print this straight off of here, and I get it in real size on a piece of paper, and then I can actually push my component through that paper and say, actually, does that line up? Or do I need to move some of those pins around a bit so that I've got exactly the right layout, and design this as a layout? Pretty easy actually to do. Yeah, okay, there are lots of other sort of bits that people do with these to make them absolutely perfect, and I'm not worrying about those too much. I just need this to be in the right place and give me the right pads so that I can bung it on the board. That's the key thing for me. So if we have a look at one that I've done earlier and that's complete, so there is the one that I set up, and I put in all the additional labeling and things so that actually that will print nicely onto the board. I've got the pads, I've got the screens printing as well to give me the labels, so that I've got a nice screen, and I can print that and checked it against the component, push the component through it, and saw that actually all of my pins were lining up into those pads perfectly, and that's all I need. And then I can, connect the two, but just like I did with the other things, other components, so that I've got the right footprint connected to my symbol, and then layout becomes easy. So now we can take that schematic and generate a PCB layout, which then we can use to actually generate this physical PCB. So I've used exactly the same technique to design a symbol and a footprint for my chronodot as well. So I've got all of my components there and laid out, and then I've connected everything up as I need it connected. So we've got our 4 connectors up here for our Christmas tree, all going down through this level shifter. We've got the connector to our screen. I've got my switch and a couple of LEDs on there, and I've indeed got my power connectors and my chronodot all laid out, all the connections done. I've used networks, I know, to do some of the connections just to make it easy. And I've got, because I know what I'm connecting, I've actually got the WS2812B LEDs up there, though I have set that not to actually be part of the PCB, so it won't come through. So then I can go and have a look at the PCB and load up the PCB for all of this. So in the PCB design, this is just a 2-layer board, and just about placing all of those components using all of those footprints and then putting in all of the tracks for it. The other nice thing that really was important with laying out this for my Christmas trees was actually working out how big those trees are and their size and laying those out. So we actually have circles on here to represent the base of each of those trees, and I'm actually printing that directly as silkscreen onto the bottom of this board, which is why the labels for these trees are backwards, because they're on the bottom of the board, which is sort of actually inverse to what it is going to be in reality, because the trees are going to be on the top, and actually all the electronics is going to be on the bottom. But once I've got those circles in place, then it becomes easy to pick where I want the connector for the Christmas trees to sit, and then can I actually put the majority of the connections to other things, like the chronodot, like the connector to my screen, like the level converter, actually underneath the Christmas trees, so that the board appears pretty blank as far as it is at the top. Actually, in the end, that didn't really matter too much. My original intention was I was going to actually expose the board and leave it so that people could see it. But I've ended up actually designing a case that surrounds it, so actually it's all covered anyway. But it was an idea to try and just hide those and to use those to give me that layout and that positioning. I was then able to order the board from PCBWay, and in 6 days I actually had 5 boards, and were able to just solder those up. And it's so much easier to solder those and give me working boards really quickly. Traditionally, I spent an awful lot of time in my case designs trying to get all of those bolts and holes and switch cutouts to actually line up properly. But actually using this technique and doing this in Blender, actually I can do it really quickly, because I can now export my 3D model of my PCB and bring it actually into the design software. So the software I'm going to use for this is a PCB 3D importer, and that comes in 2 pieces. the extractor for KICad, and then the importer for Blender, and we need to install both of those in the relevant packages. So in Blender I've been able to design this nice little case here. As we see, as I sort of move this around a little bit, we've got a nice three-dimensional case, which is where I'm going to put my PCB. I've got a nice little dome here that I'm going to place my screen in, and there's the 3 holes there for the pin headers for my trees, for my Christmas trees, and a little hole there for the switch and LED. So how did I design this? How did I make this all set up and get this all done nice and easily? Because I've done this in the past, and the big question is sizes and getting everything to line up properly. But with this model, that was really, really easy, and that's because I used a trick that I really, really like. And that trick was to use this PCB 3D importer utility, which allows me to take my design from KICad and copy it right over and into Blender. And that's a fabulous thing to be able to do. So over in KICad, all I need to do is on the PCB design is I just hit the export to PCB and then export that file to somewhere I'm going to want it. And that's it. It's really easy from that side. Over in Blender, I can then actually import it, and I've done, you can do that via the port, and then we're going to import a PCB layout, and I should have my Advent PCB there, and I've already done that. Let me just turn off all of those prints and let's have a look at my PCB, and there it is. Now I've not got this in the greatest rendering mode, but anyway, you can just about see it. There is our PCB all nicely sitting there with all the components on it. Yeah, that means that I've got something. Now, where it comes in from a size perspective, it actually is not going to come in quite at the right size. So because it's been exported assuming that I'm working in meters, and in actual fact I'm working in millimeters. So I have actually had to tell it that we need to scale it out a little bit to get it all to fit and things, but that's sort of normal sort of fudge what that one does with Blender. The nice thing though is that, you know, I've got this, I can see where all the switches are, I can see where all of the connectors are, I can see where the connection holes are. So I can add to our PCB and we can put on the case that will actually fit underneath it. And as you can see, you can actually slide the PCB directly into that case and make it all fit, make sure all the holes line up, or there is room for all of the electronics to go below it. Could even start putting on things like our screen holder on top and make sure how that will fit in and sit, and the top case as well, which sits underneath that screen. So all encoded, and you can see our nice holes are coming up there from the Christmas trees. The risers coming up, and I can actually see everything is actually going to fit. And the great surprise is, when I actually printed it, it all did fit. So, you know, I really do think this is a massive accelerator, a massively opportunity for how to actually build your cases very quickly in Blender and go from a workflow from KICad to Blender. And then once we've got our 3D models, we can send it to our printer or to PCBWay to print, or whoever we want. I thought this project was going to be too simple to put on a PCB, which is why I went down that prototype board approach initially. I was completely wrong. The outcome is so much better using a properly fabricated board. I'm also so pleased to have found this 3D PCB exporter and importer. That saved me so much time in the design process for the cases. I highly recommend it. If you like this video and it helps your learning or projects, why not drop me a cash tip using that super thanks button below the video, or the other payment methods in the description. Remember, I'm saving these up to get myself to open source in San Francisco next year, and I appreciate your help in getting there, and I hope to see you there too. Thank you very much for watching. If you enjoyed the video, then please hit that like button and please subscribe to my channel so you don't miss the next video. Bye bye for now.